Okay, I welcome you all for this next session. Okay, the resistance, temperature difference, right? So that is called as the RTD. Okay, so whether my screen is visible to you all?
Yes, sir.
Okay, now is it clear? Now
Yes,
it
sir.
is clear. Okay. So this resistance temperature difference, it may also called as the resistance temperature detectors. Ayyo. See here, it can be also call it as based on the resistance temperature difference, and also it may be call it as resistance temperature detectors. Okay, so mainly this is the real time RTD what we are using. Okay, so when it consists of a metal wire, you see here. See here, this is the metal wire which is connected by, okay, which is interconnected by the two leads. Okay, first initially the temperature before heating or before occurring, it is in measured. Okay, and again this element wire is heated. Okay, so this element can be heated using this flame. Okay, using this flame or something else. Okay, what it happens, the wire resistance will be getting increased. Okay, based on that the temperature difference we can obtain the temperature, or we can predict the temperature. Okay, so we have different types of RTD. So one is the ceramic bead type of RTD, and another one is the thin film RTD. So this is the typical thin film RTD what we are seeing in this picture. Okay, in this picture it consists of a small metal elements that is enclosed one by one. Okay, see here. Okay, so now based on this temperature difference we can able to find the temperature. Okay, so this RTD incorporates this material, may be the metal that is enclosed inside this material, may be it mainly made up of pure metals. Okay, so it consists of the pure metals or alloy. Okay, so that why we are using alloy means it can withstand high temperature. Alloy can withstand high temperature. Okay, so this we can see that the increasing resistance as the temperature increases and it conversely decreases. Okay, so whenever the temperature increases, the resistance level will decrease, and based on the resistance level, the temperature is monitored. Okay, so this the metals. So the metal that is used for measuring. Okay, so the metals that are used for measuring can withstand high temperature. Oh, see here, suppose if we are using nickel as the material, so it can withstand the temperature up to this. What is the temperature? What is the temperature range? 450 or 425 ohm. Okay, and similarly for copper we can see this, the resistance level will be 325 or 350, and for platinum we can measure up to 275. Okay, and see here the platinum can able to measure up to a temperature of 900 degrees Celsius, and for copper it can measure up to 800 degrees Celsius, and for nickel it will be able to measure 900 degree Celsius. Okay, so based on this metal element, we have, based on the metal, the temperature can vary. So, okay, so this is how the resistance or RTD is varying for different metals. Okay, so when we go for platinum, we can able to get the high temperature measurement. Okay, so this platinum, this metal that is used in here, can be able to predict the temperature up to a range of 900 degrees Celsius. See, let us consider this wire. Okay, so suppose this wire, if it is made up of platinum, it can able to measure up to a temperature of 900 degrees Celsius, and it can, the resistance of the RTD element, that is the ohm measurement, will be in 225 to 250 ohm. Okay, so this is how this reacts. Okay, so the metals that are best suited for the RTD sensors will be of uniform quality, and it can able to withstand high temperature. Okay, and only the few metals have the properties, okay, that is to be used for this RTD element. Okay, only few metals. Okay, very special metals that is only used to manufacture, used for the manufacturing of this RTD process, namely nickel, copper, and platinum. Okay, so it consists of, we can see the working principle. This RTD element consists of a long spiral wire which is insulated by a ceramic bead. So see, this is the ceramic element. Sorry. This is the ceramic bead. Okay, so this ceramic bead is surrounded by a wire. This wire may be made up of platinum, nickel, copper. Okay, based on the temperature applications we can use, or we can select the wire. Okay, imagine this is the platinum wire. Okay, imagine this as a platinum, and this wire is surrounded by a ceramic bead. What do you mean by this ceramic bead? Which is an insulator. For ceramic materials, the current will not conduct electricity. Okay, so this ceramic bead will prevent the short circuit between the two metal wire connections. Okay, so that is why we are using this ceramic bead as a material, or ceramic bead as an insulator, so it can withstand and it can able to prevent the short circuit. So for that we are using as an insulator. Okay, is it clear? Raja, is it clear?
Yes, sir.
Suppose, and similarly, as I have told you that the temperature, the change in temperature will cause the platinum wire to heat or cool. Okay, suppose if we want to dip it in the cold water, or if we want to dip it in the furnace, what it happens, the temperature will automatically increase or in decrease, or cool or heat. Okay, that proportional, or that temperature range will proportional to the change in resistance. Okay, and this change in resistance is measured using this RTD. Okay, so where this temperature is, where this RTD is mainly used, tell me, where this RTD is mainly used? Tell me, Raja, am I audible?
Yes, sir.
Yeah, tell me where this RTD is mainly used. For it is used for measuring temperature. Correct. Okay. So how, in which applications it may use? This is the real. What can we say it as RTD? Real RTD. What we are using in our day-to-day activities. Okay. So you tell me where this applications, or where this RTD is mainly used. Any idea? Microwave oven. Okay, so to monitor the temperature inside this microwave oven, we can use this RTD. Okay, so it consists of the two wide, which is mainly made by the ceramic bead. Okay, and here we are using this inconal sheath. Okay, inconal sheath. Okay, this inconal sheath is mainly used for preventing or inherent the corrosion resistance. So what do you mean by this corrosion? What do you mean by this corrosion? Rajat, tell me, what do you mean by this corrosion? Hey, am I audible? Rajat, can you hear me?
Yes, sir.
Tell me, what do you mean by corrosion? What do you mean by corrosion? Tell me, pa.
Process of rusting.
What? Come again?
Metal rusting, sir.
Rusting. Okay. So the prevention. So whenever the temperature is getting heated, okay, so the temperature increases, this coil will automatically get heated. So there will be a chance of getting contaminations or corrosion. Okay, rusted. Okay, so instead of that, it is prevented using this inconal sheath. Okay, so this is the application of this RTD. So what is the main advantages of this RTD means? Advantages of RTD. What is the advantages? It is used for it is suitable for measuring high temperature. Okay, it is used for measuring high temperature. Okay, now it has high degree of accuracy. It has high degree of accuracy. What do you mean by this accuracy? Okay, what do you mean by accuracy? Tell me.
Sir, nearest student.
The degree of closeness or correctness of the true value. Okay, and it ensures good stability and what do you mean by this repeatability?
Sir, value comes again and again.
Yeah, whenever we have to want to take the reading, it should be produce the repeated reading, the same readings. Okay, so it has a very good repeatability. Okay, so it does not need a reference temperature. Okay, so these are the various advantages. So it is used for measuring high temperature and it has to withstand a high degree of accuracy and it ensures good stability and repeatability and it does not need a reference temperature junction. It's like advantages, we have certain disadvantages in this RTD. So can you point out one disadvantages from your imagination? What are the advantages and disadvantages? Tell me. Tell me, Pa. One disadvantage is power supply is required for this operation. Okay, and the size is more than the thermocouple, and it needs it needs auxiliary apparatus to get required form of output. What it is meaning? What it means? Tell me. Third point. Third point. What it indicates? Tell me, pa. So we need an extra devices. Okay, we need an extra apparatus. We can call it as a data logger. Data logger to show the reading. Okay, so like ordinary bulb thermometer, it cannot show the reading exactly, or a reading without any external device. Okay, so we need some additional device or auxiliary apparatus to get the reading. Okay, so for that we are using this data logger, which is used to show the temperature indication. Okay, usually the data logger will be like this. Have you ever seen like this temperature reading? This is the data logger, okay, which is used to convert the voltage or the resistance voltage into the signal, okay, to the measurable readings. Is it clear to you all? Is it
Yes,
clear?
sir.
So we need some additional devices for this operation, and the resistance element is more expensive. Why it is more expensive? What is the resistance element? What are the resistance element? It is, we are using nickel, copper, and platinum. Whether this platinum is expensive or cheap?
So more
Tell me.
expensive, sir.
More expensive. So since instead of monitoring the temperature using this RTD, we are using this platinum. Okay, so with the platinum as the resistance element we are using. Okay, so the the platinum element is very expensive. Likewise, platinum, copper as well as the nickel is also more expensive. But the temperature using thermocouple measurement using thermocouple will not be much expensive. Is it clear? So the linear relationship of the resistance temperature detectors, the linear relationship of resistance temperature is given by the equation R is equal to R naught into 1 plus alpha T. Okay, what is R? What do you mean by this R? Anyone? That is the resistance at a temperature T degree Celsius. Okay. And what do you mean by this R naught? R naught is the resistance at 0 degree Celsius. And what do you mean by this alpha? Alpha is the temperature coefficient of the resistance. Okay. And now we have to measure the temperature. Okay, now we have to measure the temperature. What it happens, it will automatically getting sensed. Okay, when we want to measure the temperature using this heating element, instead of this a small firing is taking place. Okay, so the resistance R naught, okay, that is before temperature, okay, before heating, that is R can be find out using this relationship, okay, that is R naught plus 1 into R naught into 1 plus alpha T. Alpha is the temperature coefficient of the resistance. So the temperature coefficient of the resistance may vary for these different elements. What are the different elements? Nickel, copper and platinum. So based on this temperature coefficient, okay, this temperature will be getting vary. Is it clear? Raja, is it clear? Hello? Raja, am I audible?
Yes, sir.
Okay, so let me posting out a small poll. Two minutes time. Twenty-four appeared. What about the rest? What about the rest of the students? Okay, out of 40 to 37 appeared. So have you all completed? Okay. So what is the answer for this poll? RTD stands for?
Sir, resistor temperature difference.
Okay. And few students have answered wrongly. Reactance temperature difference and resistance thermal difference. So 5 students have answered, and reactance temperature difference 3 students have answered, and the reactive thermal difference 1 students have answered. So nearly 9 students have answered wrongly. So just now only I have said about the RTD. This indicates that the people, those 9 students have not yet listened. I don't want to mention the names. Okay, dear students in the class, please be attentive. Okay, so the rest of the thing is with you. So everything is monitored. Okay, so please keep in touch, right? So let me next move on to the next transducer. So are you clear with this R3D as well as this potentiometer? Is it clear to you all, Raja?
Yes, sir.
Yes, sir.
So if you have any doubt, you can post it in the chat box. If not, if you are having any doubt, also you can post it in the chat box. So if you don't want to convey the message directly, you can post it in the chat box so that I can able to understand whether you people have understood the concept or not. Okay. Kindly post it in the chat box so that let me move on to the next topic. So how can I take this? Whether you have understood the concept or you can, you people are feeling difficult to convey the message. Okay, Arun have answered, understood, sir. Okay, so the rest of the students have doubt. Okay, so should I want to repeat it again? Yeah, someone can respond it if you want to. If you want to present it again, I can present it. That doesn't matter. But the concept is you have to understand the concept. Okay, please, Raja, tell me or post it in the chat box whether you have understood or not. So without understanding the problem, I cannot move on to the next topic. That is why I am standing still. Okay. So with this 5 people's opinion, I have moving on to the next topic that is called as the, what can we call it, as the transmitter thermistor. Okay, thermistor. So have you ever seen this type of instrument anywhere else, Raja? Have you seen this type of instrument anywhere else?
So, no, sir.
You haven't seen. Okay. So this type of thermistor is mainly used in the circuit board. Okay. This thermal thermistor is the word. It is the combination of the word thermal as well as resistance. What do you mean by this thermal? What do you mean by the term thermal?
So, heat transfer.
Heat. Thermal
Transfer.
means no. There is no thermal means heat. Okay. So thermal and resistance, that is heat and resistor. Okay. So the name itself we can say it as thermal with resistor. Thermistor is equal to thermal plus resistor. Okay. So the heat can be sensed using the resistor. Okay. So the thermistors are and RTDs are the temperature sensitive sensors. Okay. The temperature sensitive sensors. Okay. These thermistors are Thermistors are non-linear devices. What do you mean by these linear devices and the non-linear devices? Tell me. So it can move linearly, or the readings can be moved. The readings we can obtain can be interpreted in a linear mode. Okay. So this resistance, the thermistors in thermistor, what it happens means the resistance will decrease, okay, with an increase in temperature, but but at a much faster rate than RTD. Okay, here the temperature, the resistance level will increase. Okay, so how much time, how much it can vary, the resistance will decrease. Okay, so when compared with the resistance RTD, the resistance level will increase or decrease. How much time it can increase or decrease means the resistance can change. The resistance can change by more than 1,000 times. Okay, 1,000 times. So what happens if it increase or if it can change 1,000 times means the thermistor can sense the minute changes in the temperature. Okay, so the thermistor can sense minute change in temperature, and therefore this thermistor can able to predict very high accurate readings. Okay, is it clear? Ajay, is it clear?
Yes, sir.
Now this the basic equations that is given by the resistance change, the basic equation is given by RT equal to R naught of e power beta 1 by t minus 1, sorry, 1 by t naught. Okay, so this is the relations. For RTD, it is R is equal to R naught of 1 plus alpha t, and for this thermistor, RT is equal to R naught of e power beta into beta into 1 by t minus 1 by t naught. So what is the what is the R naught? R naught is actually the resistance at a reference temperature. Okay, at T naught degree Celsius. What is RT? That is the resistance at a measured temperature, that is at T naught degree Celsius. And what is beta? Beta is the constant value. Is it clear? So the thermistors are generally, see here, these thermistors are generally small and expensive, inexpensive devices. It is very, very cheap. Okay. So this, it is mainly made up of, this element is mainly made up of oxides, made up of metal oxides. Okay. What are the metal oxides? We have chromium, nickel, manganese, and cobalt. Okay, so these are the various metal oxides that is used in the manufacture of this thermistor. Okay, so the metal are oxide through the chemical reactions, and it is ground by the fine powder. Based on the fine powder, this entire material is getting manufactured. Okay, and how it is manufactured? See here, this is the two element. This is the element. See, this is the bead type of thermistor. Okay, so there will be two wire, that is A and B. Okay, so see, it's like here also there is A and B, which is interconnected. Okay, so it is interconnected. Okay, so whenever the heat is applied in this area, okay, so in this material, this hard junction is coated with the metal oxides of manganese and copper. So this is how it looks like. Okay, is it clear, Raja? Is it clear?
Yes, sir.
So it consists of the metal oxides. When the hot and cold junctions will be appearing on this area, it is interconnected and it is meeting at one point. So that point, it is covered by the metal oxides of chromium, nickel, manganese, and cobalt. So these element, or these will be acting as a semiconductor. Okay, so generally we have two types of thermistors. One is the rod type thermistor, bead type of thermistor, and the disc type of thermistor. Major, we will be classifying into two types. One is bead type thermistor and another one is the disc type thermistor. Okay, so we have generally we have two different types of thermistors. We have already seen in the lab classes. We have the positive temperature coefficient and the negative temperature coefficient. We can call it as PTC and NTC. Positive temperature coefficient and negative temperature coefficient. Okay, positive temperature coefficient and the negative temperature coefficient. See here, if already we have seen in the lab class, if K is positive, what it happens? The resistance will increase with increasing temperature. Okay, and the device is called positive thermistor, or we call it as posistor. Okay, and similarly, if K is negative, what it happens? The temperature resistance will decrease. The resistance will decrease with increase in temperature. Will decrease with the increase in temperature. Okay, so this is called as the negative temperature coefficient thermistor. Okay, so this NTC, negative temperature coefficient, is mainly used for temperature sensing devices. Okay, whereas this positive temperature coefficient is mainly used for electric current control devices. Okay, so the temperature range, the thermistor range will be from -80 degrees Celsius to 150 degree Celsius. So it can able to predict the temperature up to a range of from minus, very important, very important. Okay, you can expect an MCQ. Okay, so the thermistor can able to measure the temperature range from dash to dash. Okay, so what is that answer is -80 to 150 degree Celsius. Okay, is it clear?
Yes, sir.
Okay, so we have certain advantages. What are the advantages? We have, it produces more accurate, sorry, more accurate output and faster response. And number two, it is suitable for the usage in remote location. Okay, so almost it can be manufactured, it can be manufactured to any shape and size. Okay, and number four, we have a high degree of accuracy. And for number five, we have good stability and repeatability. Okay, and it can withstand mechanical and electrical stresses. Okay, so these are the various advantages. So okay, so with this I am stopping the class. Okay, so if you have any doubt in this thermistor, you can tell me. Any doubt in this, Raja?
Sir, no, sir.
Is it clear? So
Yes, sir.
what is the operating range of thermistor?
Sir, minus 80 to 150 degree.
Minus 80 to 150 degrees Celsius.
150 degree.
Okay. Okay, good. So with this, I am stopping the class. Let us continue in the tomorrow's class. Okay. So thank you everyone for your kind cooperations. Thank you.
Thank you, sir.